have seen, the burners in a boiler provide the combustible mixture of air and fuel oil that is burned in the boiler furnace. As seen in this view of a typical burner mounted in a furnace wall, the burner's atomizer reduces the fuel oil to finely divided mist-like particles. That is, atomizes the fuel oil. Then the air doors and the bladed cone in the burner register mix these particles with air to form the combustible mixture. Although all burners perform these two functions, atomizing the oil and mixing it with air, different types of burners atomize the oil in different ways. Most burners are mechanical atomizing burners. Some mechanical atomizers are the pressure type. There is also a return flow pressure atomizer. Another mechanical atomizer is the rotary cup type. A few burners use steam atomizers. In this film, we will see how these different types of burners work. The forced draft blowers send a strong blast of air to the burner. The fuel oil pump sends the oil through the heater where the oil is heated to give it good flow qualities. Then the oil is pumped to the burner. This simplified cutaway of the burner shows how the fuel oil is forced through the burner barrel to the atomizer nozzle, where a series of passages guide the oil to the sprayer plate. The sprayer plate makes the oil rotate at high speed, breaking up the oil into particles. The oil leaves the atomizer as a hollow, mist-like cone or spray. Meantime, in the burner register, air provided by the forced draft blower is given a rapid rotating motion by the air doors and bladed cone and mixed with the oil spray. The mixture of oil and air enters the furnace where combustion takes place. The diffuser prevents the air blast from blowing the flame from the atomizer tip. Now let's see the action of the sprayer plate in more detail in an exploded view. You can see how the oil passages in the atomizer nozzle guide the oil into the slots of the sprayer plate. How the slots give the oil a very rapid whirling motion in the whirling chamber. And how the whirling oil emerges from the sprayer plate orifice or opening as a hollow cone of mist-like oil particles. You control the firing rate of the burner by varying the amount of fuel oil flowing through the burner. Of course, you must make corresponding changes in the amount of air reaching the burner when you change the amount of fuel oil. When you increase the pump pressure on the fuel oil line, you increase the quantity of oil going through the burner. When you decrease the pressure, you decrease the quantity of oil. However, when you want an increase in the firing rate, the sprayer plate in use at the time may have too small a capacity. That is, too small an opening to provide the necessary quantity of oil, even with oil pressure at maximum. You must substitute a plate with a larger capacity. When you want a decreased firing rate, the sprayer plate's capacity may be too large to properly atomize the reduced quantity of oil. You must substitute a plate with a smaller capacity. Frequent changes are necessary because the operating range of a given sprayer plate is very limited. Controlling the forced draft blowers is the principal method of controlling the quantity of air reaching the burner. For example, to increase the air a moderate amount, you increase the speed of the blower in service. Or, if even more air is needed, you cut in another blower. You can make minor adjustments in the air supply with the air doors. In this type burner, only part of the oil that goes through the burner is actually burned. The remainder returns to the fuel oil pumps. Air doors and a bladed cone give the whirling motion to the air that enters the register to mix with the oil, as in the burner seen previously. The oil, heated and under pressure, is forced through the inner tube of the burner barrel to the sprayer plate, where the oil is rotated in the whirling chamber. The oil leaves through the sprayer plate orifice. Centrifugal force sends some of the oil into the return line and back to the fuel oil pump. The remaining oil continues through the orifice into the furnace. At the burner's maximum firing rate, practically all the oil enters the furnace. At the minimum firing rate, practically all the oil